in Australia, Hexagon has partnered to provide autonomous road trains to haul millions of tons of material over 100 kilometers from pit to port for export. It's just astounding. Lee Baldwin is Director, Core Autonomy Segment at Hexagon. And you're going to tell us about these things, which we talked a little earlier. They just blow my mind. But in any case, let's hear more. For starters, what are the benefits to using road trains in mining operations?
Well, maybe it's a good time to start. What is a road train?
What is a road train?
So a road train is something that is a term typically used in Australia.
Yep.
It's for a semi-truck that has multiple trailers.
Right.
So they'll have at least two and a third one.
Right.
And so they're for long haul operations from the pit to the port.
Right.
So that's where, and you could, rail is usually used or something like that, but road trains. So the benefits is access to stranded ore deposits. And what is a stranded ore deposit? It's something that was not economically viable to go after for whatever reason.
Right.
In the case of Australia, it's quite often it's labor.
Right.
The shortage of labor, and you just can't get truck drivers to do it. So that's where a road train comes in.
Okay. So suddenly they're able to do this transportation with one driver, right? Okay. Why not use a large, one of these big, rigid haul trucks for the use?
Well, I think the big key is we're taking the driver out. Yeah. So these large haul trucks that you'll probably see in the hall, those are typically used for in-pit. Right. So if you tried to use a large haul truck on a 100-kilometer road, it just wouldn't work well. Right. The tires would heat up, and that would be problematic. So they have to use either traditional railroads or a semi-truck to do it.
Right. And forgive me, because I think I did say one driver. The whole idea here is zero drivers.
Zero drivers. It's not platooning. It's fully autonomous operations with no drivers.
Yeah. So how does autonomy fit in then in the big picture?
So the autonomy is really two parts. You have a command and control part, which orchestrates the fleet of trucks, keeps them safe.
Yeah.
And then you have the whole machine autonomy layer, where you have the drive-by-wire layer that interface with the actual truck systems and gets feedback from them. Right. And then you have the subsystems for a robot. The path planning, where does it go? What does it perceive? Does it see? Right. Positioning, where is it on the planet? Right. So you put all that together, and then you orchestrate it with a system.
And when you say that automated road trains improve mine site safety, how does that work exactly?
Well, the robots do what you tell them to do.
Right.
So, and the other thing is they will always do what you tell them to do. So if it's raining, you can do things where you derate the entire fleet. So we're going to have 120 trucks running on this haul road. Right. So if it rains or something, you derate the whole system, because they're going to be designed to go 80 kilometers an hour. So if it's raining or something like that, you could derate the system and it would be safer. Plus, you just take the human out of the equation, fatigue.
Right.
You no longer have to worry about drivers falling asleep, because it's very monotonous.
Yeah, I'm sure. What can't they do or shouldn't do?
The limitations it's just in general with road trains, because one thing you're doing is you're taking a semi and you're running 300 tons with it. So one of the limitations is the amount of time it takes to stop. It could take 300 meters to stop.
Yeah.
So you really want to keep the machines away from each other, for one, and then you have to know exactly where that machine is.
Right.
So you know if it ever did something it wasn't supposed to do.
Are there any other opportunities out there for autonomous road trains?
There are. It doesn't necessarily have to be a 100-kilometer haul road.
Yep.
It could be something where you have a similar scarcity of labor. You just can't get them, or they're just too expensive.
Yep.
And a repetitive operation. So there are agriculture use cases for rehandling grain in a grain stockpile. Things like that. But it could be, the sky's the limit for what you could do.
can you describe for us the journey of Hexagon from where it was, meaning platforms, on-road autonomy, to where it's going, which I gather is production-ready off-road autonomy?
Yeah. So Hexagon Mining has had decades of experience with fleet management and orchestrating manned mines.
Right.
So they know how to efficiently move machines around a mine as well as do it safely. So we're leveraging these systems that have been around, lots of hours on them, and then we're putting together with a business that Hexagon acquired for research and development autonomy, and we're utilizing that to take the Kenworth trucks that we're converting to robots. They're actually not really smart trucks.
Right.
And we're making them extremely smart.
Yeah. So what is off-road autonomy in the broader sense? And what industries, beyond even mining, does it relate to?
So off-road autonomy cuts across mining, agriculture, construction.
Right.
And you got to look at the difference and why would you focus on off-road?
Right.
Because you can limit the environment and the craziness that goes on in the real world. Because you can put a fence up to keep people out from going across it.
Right.
And that's one of the things, if you look at on-road autonomy, there's billions and billions being spent on it. Right. But one of the issues is the crazy human. And what do you do with that? We remove as many humans as we can to control the situation where you can't do that in real life.
Right. So there are clear advantages with regard to safety. What about efficiency?
So efficiency, from a productivity gain, you no longer have to worry about shift changes with drivers. So you can run 24 hours a day, and you don't need 4 drivers and all the shift, or 2 drivers for 2 12-hour shifts. But you don't need to do a shift change. Right. Yeah, you don't need to have food breaks or anything like that. So you immediately get efficiency gains on that. Plus, you don't have fatigue events if somebody gets tired and they have to go do something.
Right.
Yeah.
Now, this basic idea, autonomous solutions, is pretty widely understood. What is Hexagon doing that is yours alone?
Well, some of the industry firsts and road trains are going to be this 100-kilometer haul road has underpasses, so it doesn't have line of sight. So we're using the GNSS system that Hexagon's developed, but you can't solely rely on it to drive you down the road. So we have these underpasses. We have a 70-meter tunnel that we have to navigate. So again, no line of sight, so we have to develop new technologies to navigate the road train, and then indoor dumping and indoor loading to a plant. So these are all firsts that we will be doing here at Hexagon.
It's interesting. And what does it mean to have a production level drive-by-wire kit?
Yeah, so the drive-by-wire system is important because we're not owned by an OEM So what we do is we have to take somebody else's machine and convert it into a robot. So, and the key is it has to last. Yeah. So that's the big difference between a research vehicle and a production level, and it has to have certain safety certifications to do it, since you're actually controlling the machine, the steering, and all that. So we developed some key components that are hardened like an actuator for steering.
Yeah. Yeah. And can you describe, let's look at the big picture, the autonomous solution that Hexagon provides. How would you describe that?
So it's really an end-to-end solution that goes from the orchestration of all the trucks to the safe navigation of that truck down that long haul road.
Right. In our discussions here on stage this morning, we've often used the metaphor of the journey that we are on in one thing or another. It's not even a metaphor in your case. You're on a journey. You're on the road. Yeah. How far along the road is the road train journey?
Well, right now we have more than 40 road trains commissioned. They're not in autonomous mode yet, but next year, once we have milestones met, we will start to turn them into autonomous machines in Western Australia.
It's really something. And it is kind of mind-blowing, really, when you think about the size, as you were saying, of these things. It's just amazing to hear it.
It is. It's quite exciting to be part of it.